Hi everyone, I'm going to show you guys of how to integrate x squared over root x squared minus 25. So we could write this as x into x root, x into x, open brackets, x squared minus 25, close brackets, to the power minus half. Because we can take the denominator up, right? So when you take it up, it becomes minus half. Now I'm going to use integration by parts. The formula is I equals u v minus v dot du over dx dot dx. Now let's take one term as u and the other term as dv over dx. So u we can take as x, right? This term over here, because the differentiation of x is 1, and dv over dx we take as x into x squared minus 25, close brackets, to the power minus half. So now let's find v. So to find v, we need to integrate this. So let's write v equals the integration of x into x squared minus 25 in brackets to the power minus half dot dx. Okay, so for this you could take a substitution of u equals x squared du over dx. Now let's take t, since we have u in the formula. Let's take t equals x squared dt over dx equals 2x. Right, so you go back into integral. Now it's x into, instead of x squared I'm going to write t minus 25, close brackets, to the power minus half, and instead of dx I'm going to write dt over 2x. As you can see, dt over 2x equals to dx. You can cancel off the x, you can take half outside, and then all you have to integrate is t minus 25 to the power negative half. And when integrating that, all you have to do is just add 1 to the power and divide it by the power, and then you multiply it with half. So you can see these two will cancel off, and you end up with t minus 25 to the power half. So it's gonna be x squared minus 25 in brackets to the power half. So let's go back into our question. So we know u equals x, and now we know v equals x squared minus 25 to the power half. Now let's find du over dx. Du over dx equals 1. So you go back into integral. So u into v, so that's x into x squared minus 25 in brackets to the power half minus v x squared minus 25 in brackets to the power half into du over dx, which is 1. So now all you have to integrate is with the integral of you should integrate x squared minus 25 in brackets to the power half, right? So now let's take another substitution. So let's take a substitution of w equals 5 sec x. So the reason I'm taking 5, I'm sorry, it's not w, it's x equals 5 sec w. Yeah, like that. Okay, so the reason I'm taking it like that is, now we have x squared in the integral, right? So if it's x squared, you can see when I take a substitution of x equals 5 sec w, you can see if I square this, I get 25 sec squared w, right? Then it's going to be 25 sec squared w minus 25. You can take 25 outside, right? And then it would be 5, and you'll have sec squared w minus 1 inside, which is tan squared w, and root tan squared w is tan w. So therefore you can cancel off the roots. That's why we take this substitution. So before we go any further, we need to differentiate this. So dx over dw equals 5 sec w tan w. That's the differentiation. But if you guys have any doubts, please drop a comment. I'll help you guys out. Okay, so now you can write dx equals to 5 sec w tan w dot dw. You go back into your integral. Now instead of x squared, I'm gonna write 25 sec squared w minus 25 in brackets to the power half, and instead of dx, I'm gonna write 5 sec w tan w dot dw. Okay, so now you can see 25 you can take that out, so it's going to be 25 to the power half, so that's 5 you can take it out, and we have another 5, so it's basically 25, and sec squared w minus 1, so it's going to be sec squared w minus 1 to the power half. So this is tan squared w, and the root gives you tan w, right? So it's tan w into sec w into tan w. Okay, now this is gonna be a bit complex, but let's do it anyways. So it's gonna be sec w into tan squared w. So tan squared w, I can write it as sec squared w minus 1 dot dw, right? So now you could expand the brackets, and we'll have sec cube w minus sec w. So now we could integrate them separately. So let's leave the 25 outside for now. You don't have to worry about that. So when you integrate sec cube w, you can break this into 2. Sec w into sec squared w. Okay, so you take u as sec w, and you take dv over dw as sec squared w. So then du over dw equals tan w sec w. V equals to tan w. The integration of sec squared w is tan w, right? So using your formula u into v, so that's tan w sec w minus your integral. So you have tan w into tan w sec w. Now you can see we get something similar to what we had previously, right? So you can write tan w sec w minus, and the same thing over here, you can write sec cube w minus sec w, because previously we had sec w into tan squared w2, right? So sec w into tan squared w, so tan squared w I can write it as sec squared w minus 1. So when you expand that, you get this. That's why I wrote it down like that straight away, because now you guys know it, right? But in the question previously we had minus sec w, right? So including this, we also had minus sec w, like this, right? Now don't get confused. If you guys have any doubts, please drop a comment. So just ignore the 25 for now. So now you can see, if you expand the brackets with this negative sign, so we have tan w sec w minus the integration of sec cube w plus the integration of sec w dot dw. Now don't get confused, because this is the integral of sec cube w, Alright, so sec cube w equals to this right here. I still didn't add this part into our integral, so we'll keep that there for now. So now what I'm going to do is, now since we have minus sec cube w on the right side, we could take it onto the left side, right? So then we'll have 2 with your integral sign, sec cube w dw equals to tan w sec w minus, sorry, plus the integration of sec w dw. Now let's divide both sides by 2. So we have the integration of sec cube w dot dw equals half into tan w sec w plus half with your integral of sec w. So now what you can do is, now this is sec cube, right? And now we have negative the integration of sec w. So remember I told you guys to keep 25 outside for now. So now let's write our final integral. So now it's 25 open brackets. Now instead of writing sec cube w, I'm gonna write half tan w sec w plus half integral of sec w dot dw minus, now 25 has to be multiplied by every term, right? Minus the integration of sec w, like that. Now let's focus on the terms we have inside the brackets. So it's half tan w sec w plus half, sorry, it's half minus 1, right? So you could write minus half into sec w dot dw. Now let's focus on the integral of sec w. So how do you integrate sec w? Well, I've done this a couple of times, but I'll do it again because you guys don't have to scroll down finding the video. So you could write this as 1 over cos w, right? And 1 you can rewrite as sine squared w plus cos squared w, right? So now let's break them down into 2 different integrals, like this, plus the integration of cos w. So for the integral on the left side, you could take a substitution of, let's say, z equals sine w, dz over dw equals cos w. So now it's sine squared. Now instead of sine squared, I'm going to write z squared over, and instead of writing dw, I'm going to write dz over cos w equals to dw. So instead of dw, I'm going to write dz over cos w, and we have cos w in the denominator of the integral, right? So cos w into cos w gives you cos squared w. So if z squared equals sine squared w, then 1 minus z squared equals cos squared w, right? So then you can write z squared over 1 minus z squared dot dz. So now let's use polynomial division. We could break this down. So you can do z squared divided by minus z squared plus 1. Z squared divided by negative z squared is minus 1. Minus 1 into minus z squared is z squared. Minus 1 into 1 is minus 1. So you can put 0 there. So 0 minus minus 1 gives you 1. So it's 1 over 1 minus z squared minus 1. This equals to z squared over 1 minus z squared. Let's go back into our interval. So it's 1 over 1 minus z squared minus 1 dot dz. So now we can break this fraction down into partial fractions. So 1 over 1 minus z squared, you can write it as let's do it like this: 1 over 1 minus z into 1 plus z. This equals to a over 1 minus z plus b over 1 plus z. So then 1 equals to a into 1 plus z plus b into 1 minus z. When z equals to 1, a equals to half. When z equals to negative 1, b equals to half. Same thing. So we got half. So it's 1 over 2 into 1 minus z plus 1 over 2 into 1 plus z minus 1. Too many integrals. So the integration of 1 over 2 into 1 minus z is half into, so it's easy. I'm gonna do it straight away. So it's negative half into ln 1 minus z. That's your integral. And the other one is plus half ln 1 plus z. Now if you guys need explanations on these, you can drop a comment. The reason I'm not doing it is because it's really easy. You can just do it in your, you can do it mentally. So, and the integration of 1 is z, right? So you could rewrite this as half into ln 1 plus z over 1 minus z. Since we have a subtraction, since we have minus, when two ln functions get subtracted, you should know it's division of the terms inside the brackets. So this is your integral. You need to remember that we had, now this was our integral, right? Then we broke it down into this, and we also had the integration of cos w. The integration of cos w is sine w. So we need to add sine w over here. So the substitution we took was z equals to sine w. So sine w is z, right? So you can see these two cancel off. So then this shows that the integration of sec w equals to half ln 1 plus sine w over 1 minus sine w, right? Okay, so now we basically did everything. We just need to add everything up. So let's go to what we had. So this is what we had, right? 25 into this whole thing. So it's basically this into 25. So it's gonna be 25 into half tan w sec w. It was minus half sec w. So minus half sec w, the integration of sec w. So it would be minus half into half ln 1 plus sine w over 1 minus sine w. So now it's 25. We could leave 25 out. Let's leave that outside. 25 into half tan w sec w minus 1 over 4 ln 1 plus sine w over 1 minus sine w. Okay, so now we can go to the substitution we had first. Our first main substitution was x equals to 5 sec w. X equals to 5 sec w. But you know, we need to add this up with this guy over here, because you can see we had x into x squared minus 25 in brackets to the power half minus this integral. So the integral we had just down below is the answer we had is for this integral right here, x squared minus 25 in brackets to the power half. So we need a negative sign in front of it, like this, over there, and then we add x into x minus 25 to the power half. Let me just double check everything. Yep. Yeah. Okay. Now let's go back to our substitution. So sec w equals x over 5, and you can write, let's do it like this. So we write x over, why did I erase it? X over 5 equals sec w, then x over 5 equals 1 over cos w. Cos w equals 5 over x, right? So then tan w, so we could write, if cos w equals 5 over x, this is going to be your adjacent side and this is your hypotenuse. So then to find the opposite side, it would be x squared minus 25 and the square root of the whole thing. This is your opposite side. So then sine w is opposite side, x squared minus 25 over the hypotenuse, which is x. So then tan w sec w would be, so it's root x squared minus 25 over x into sec w, which is x over 5. So you can see these two cancel off just like that. And oh, hold on a minute, it should be root x squared minus 25 over x. That's sine w. I'm sorry, that's sine w. So we have over cos w, we need to put cos w, so that's 5 over x. Now this is the question. So now you can see these x, that x will cancel off, and then you can take the x up, so it's x root x squared minus 25 over 25, right? Because 5 into 5 is 25. Okay, so this is tan w sec w. Yeah, I don't see any mistakes. Yeah, let's write the final answer. So it's x into x minus 25 into to the power half minus 25 into half into x over 25 into root x squared minus 25 minus 1 over 4 ln. So we have 1 plus sine w, so 1 plus root, so it would be like this, x plus root x squared minus 25 over x minus root x squared minus 25. Okay, let's expand the brackets. So it would be, you can see these two, when you multiply it together, they'll cancel off, and you'll have x over 2 into x minus 25 to the power half plus 25 over 4 ln x plus root x squared minus 25 over x minus root x squared minus 25. Yep, this is your final answer, and don't forget plus c. I think I might have gone the long way because I broke down x squared over root x squared minus 25 like this. I feel like if I took the substitution of let's say like the substitution like over here, x equals phi sec w, if I took that substitution at the start, I think I could have solved this question even faster. But anyways, yeah, I just continued. So that's everything for this question. If you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Thank you so much.